Now the first question is, without actually performing the long division, state whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. So here in this case, what we have to do here is, first of all, we have to find out that these form, they are in simpler form or not. That means whether they have common factor. First we have to make it in the simpler form, and then we have to find out that whether the denominator is in the form of 2 to the power m into 5 to the power n. If this is the case, then we can say whether it is terminating decimal expansion or not. So let us take the first one, that is 23 by 8. Now 8 is what? 8 is 2 into 2 into 2, that is it is 2 cube. You can write it as 23 by 2 cube. Now here if you see that 23 has no factor as 2. So now this is in the simpler form. First we have to say that it is simplest form, then only we can go ahead. Now 8 can be written as 2 to the power 3, and you can also add 5 to the power 0. So now 8 can be written in the form of 2 to the power m into 5 to the power n, where m is 3 and n is 0. So when this denominator can be written in the form of 2 to the power m and 5 to the power n, then the given number means 23 by 8 has a terminating decimal expansion. Let me take another example. Say this one. Here 35 by 50 is there, but we know that 35 by 50 is not in the simplest form. So how to do it? First of all, we will find out the highest common factor of these two, and the highest common factor is given in the question, which is 5. So first we divide 35 by 5, the numerator, and also denominator by 5. So what do we get? We get 7 5s are 35 and 5 10s are 50. Now 7 and 7 by 10 is in the simplest form. The next thing is to take the denominator and see whether this denominator can be written in the form of 2 to the power m into 5 to the power n. So 10 is actually equal to 2 into 5. So here m will be 1, 2 to the power 1, and 5 to the power 1, that is n is 1. M and n are 1. So now this 10 can be represented in the form of 2 to the power m into 5 to the power n. That means this given number, that is 7 by 10, has a terminating decimal expansion. And I hope you'll be able to do this. Let us take one more. This I am not taking just because the factors are already given. The factor is already given, 2 to the power 2 and 5 to the power 7 is there, right? But 7 to the power 17 is also there. So this surely says that because of the addition or because of the presence of 7 to the power 17, this is not going to give you the result. But in the fourth part, let us say we are taking 77 by 210. In this, the HCF of 77 and 210, if you find out, it will be 7. So you divide 77 by 7 and 210 by 7. You get 11 and 30, 11 by 30. Now let us take 30. 30 is what? 2 15s are 30, 2 5 3s are 15. So now this can be written in the form of 2 into 5 into 3. So this is 2 to the power 1, 5 to the power 1, but we have an additional number which is 3. So this 30 can be written in the form of 2 to the power m and 5 to the power n, but there is 3 also. That means the given number has non-terminating repeating decimal expansion. Same goes with this. Same logic goes with this. Write down the decimal expansion of the following rational numbers by writing their denominators in the form 2 to the power m into 5 to the power n, where m and n are the negative integers. So same thing we are going to do, same thing the way we did in the previous part, question number 1. So 3 by 8 is what? 8 is 2 to the power 3. So 2 to the power 3 can always be written in the form of 2 to the power n into 5 to the power m, that is it is 2 to the power 3 into 5 to the power 0. So now this means this given number has a terminating decimal expansion. So how do we write in the form which is given in the question? So this, just understand what I am trying to do. See, this is 3 by 8. 8 is 2 to the power 3. Okay. Now, what is the power of 3? 2 power of 2, which is 3. So we have to write exactly the same power of 5 also. But as we have written 5 to the power 3, why I have done this, I'll just tell you. If it is of the power 3, 5 should also have the power 3. And in the numerator, because I have added this, I have to multiply 5 to the power 3, because this needs to be cancelled, because we cannot add a number just like that. We have to have a numerator and denominator. So here, if you see, this is 3 and this 5 cube is nothing but 125. This is 2 cube, 2 cube is 2 cube and 5 cube. But why I have taken 5 to the power 3 is 2 and 5 can be taken. You know, 8 to the power n into b to the power n is ab to the power n. So here you can take 5 into 2 or 2 into 5 rather to the power 3. And what is this 2 to the power 2 into 5? This is 10 to the power 3. So this is 1000. And 3 into 125 is nothing but 375. So by 1000. So how do we write it? 1, 2, 3, 3 zeros. So 1, 2, 3, 0.375. This is the answer. I'll take one of these. Say, let me take this one. Okay. 7 by 80. Now 7 by 80, first of all, let us find out the factors of 80. So 2 in 40 is 80, then 2 20, 2 10s are 20, 2 5s are 10. So these two can be written as 2 to the power 4 and 5 as 5 to the power 1. Now 80 can be written in the form of 2 to the power m and 5 to the power n. That means that this given number has a terminating decimal expansion. This 2 to the power m and 5 to the power n has given us this idea. Now how to write this in the decimal expansion form? What we will do, this is 7. Now this is 2 to the power 4 into 5 to the power 1. But I need 5 to the power 4. So how do we do it? I multiply 5 to the power 3 here in the denominator and 5 to the power 3 in the numerator, because I want to make this 5 also as power of 4. So this will be 7 into 5 cube is 125, and this will be 2 to the power 4. This is 5 to the power 4. 2 to the power 4 into 5 to the power 4 is 5 to the 10 to the power 4. So this is 10 to the power 4, which is nothing but 10,000. 7 into 125 is 875, and this is 10,000. So now 1, 2, 3, 0, 0.0. So 0.0875 is the decimal expansion. So let us take one more. Say I am taking this one. I'm not taking this one because this is pretty easy. This is 2 to the power 4, 5 to the power 7, and you just have to multiply 2 to the power 3 in the denominator and 2 to the power 3 in the numerator, because you want 2 to the power 7, because this is 5 to the power 7. So just you have to do multiply them and just divide, because this will be 10 to the power 7. This is 10 to the power 7, and when you multiply 129 by 8, because 2 cube is 8, you will get this number 4128. Okay. So sorry, this is 2 to the power 5. This is not, this is 2 square. 2 to the power 5, and this is 2 to the power 5. So essentially you have to take 5 to the 10 and take that to the power 7, and this number will be 2 to the power 5 is 32. Multiply 32 by 129, 4128, divide by this number, and you get this decimal. So I was taking this one. Now 625 can be written as 625 is nothing but 5. 5 ones are 5, 5 to the 10, 5 5s are 25. So this is 5, 5 to the 10, 5 5s are 25, and 5 5s are 25. So this is nothing but 5 to the power 4. So we can add just a 2 to the power 0 with this, and we can say that this is a terminating decimal expansion. So how do we do it? This 14588 now divided by this number, which is 2 to the power 0 into 5 to the power 4. Now what we want is that I want 2 to the power 4 in the denominator. So I multiply 2 to the power 4 denominator, because ultimately I want 2 to the power 4 in the denominator, and multiply 2 to the power 4 with the denominator, or with the numerator. So here you get 10 to the power 4 in the denominator, and numerator 14588 into 2 to the power 4. 2 to the power 4 is 16. So when you multiply this, you get 233408. So this is 10 to the power 4, which is nothing but 10,000. So 1, 2, 3, 4. 23.3408 will be the decimal expansion. What can you say about the prime factorization of the denominator of the following rational? Here, if you see that this number starts from 1, means after decimal, ends at 8, ends at 9. There is no repetition. But this bar says that, for example, this one, we will have 142857. Then again, we will have 142857, like this. But here, if you see, this is 120, 1200, 12000. So this is also not terminating, but it is not repeating. Here it is not terminating, but it is repeating. So if you see that 43.1, this one 43.123456789, this is a terminating decimal expansion. That means the denominator will be of the form 2 to the power m into 5 to the power n, where m and n are non-negative integers. In this, because it is a non-terminating decimal expansion, we know that the denominator will not be having factor 2 or 5. Same is the case with this. But here it has non-terminating decimal expansion. So the factors again will be, these three have this similar explanation. This one also, because it is not terminating. This is also not terminating. The not terminating means the denominator will not have a factor either 2 to the power m or 5 to the power n, any factor.